your time. So we're going to figure out cost. It'll be A equals our present cost, like our starting cost, is this 31,231. It'll be 1 plus. Our rate is 3.7%, so 0.037. Over our number of compounds, well, it's just annually, so it's just 1. So you don't actually need to write it. Let's get rid of that. 0.037. And then times NT, well, the T is 20. So that's going to be the first one, is just plugging that in to get our cost in 20 years. If college continues to increase, I kind of feel like it's got to hit some sort of ceiling at some point. But
yeah, this is about interest, not interest and inflation, but yet here we go. It's like
right. Yeah, because this is crazy, right? 60, almost 65,000 a year for college, but if it continues going up, it's not that unreasonable. I mean, some colleges now are like, get a private college for plus 50 grand a year, right? So yeah. And then you get in debt and don't have any money after that. You got to get a good job just so you can pay the debt that you got.
Sounds like you might be able to solve it here. Like you might be able to solve it just on this one.
I don't have a lot of college debt.
I know, just like the way you said it, it sounded like you're the way the person experience it. Like, oh, this is happening.
Well, I don't have that much. My wife has more. That work to pay off the debt. All right, the next one, college savings plan, such as the 529 plan, allows individuals to put aside money to help pay for college later. So, like, oftentimes parents will set one of these up. So, when their little kid's born, they can set up a college fund, and then when he's 18, then you got some money to pay for college. All right, so one such plan offers a rate of 2% compounded continuously. How much should we put in a college savings plan in 2016 to pay for 1 year of college at a 4-year private college for incoming freshmen in 2034? All right, so we want to know how much to put aside in 2016 so that this kid is going to have enough to pay for 1 year of college in the year 2034. How much will we need to put in a savings account now? So this is going to be like our future value, because in the future we want this much money. So we're going to say 64,589.36 equals, and we want to know the present value. How much do we need to put away now? So that's going to be our P. And we know everything else. We know it's 1 plus. Our rate is 2%. And actually, it's continuously. I should write a little bit further. It's continuously, so it's going to be our E. So it's going to be our PE. So the rate is 2% compounded continuously. So it's going to be RT, which is 0.02 times the time. What should be the time here? Yeah, it's going to be 18. Yeah. It's 2016 to 2034, which I guess makes sense, right? If you have a kid born, then you would pay for 18 years. All right, so let's figure out how much we're going to need to put aside now, so that in 18 years we'll have enough to afford a year of college. Of course, you got 3 other years still got to pay for. All we're going to need to do then is just divide, right? Just divide this by e to the 0.02 times 18. So let's see, 64,589.36 divided by e to the 0.02 times 18. And we got to put aside a present value of $45,062. Probably not going to happen. Most often, you wouldn't do a plan like this where you just set aside a chunk. You would pay a certain amount every year. You would put some, let's say you're going to put in like $2,000 every year, and then we have something kind of similar to that. Yeah, it's not a 529, but so it's a little more like different. But we have like a whole life insurance policy thing that's set up, so that like if we have term life insurance too, but whole life insurance policy basically works that you pay money into it, and if you die or whatever, then they get a certain amount. So it's like 100,000. But if not, then you still have like a cash value after a certain number of years. So we could like in 18 years or whatever, 15 years, just like take the cash value out of it. It's kind of like a saving thing. So it's gonna be kind of something like that. But, yeah, college, if it's that expensive, then there's no way to have that much saved. You know, $65,000 over 4 years.
Right.
Right. Not gonna do that on a teaching salary. All right, let's look at the next one, 55. All right, so in 2009, if you guys remember, when Obama was in office, how old were you guys, like 6, 7 years old? That's crazy. All right, so there was a stimulus package in 2009, and it was $787 billion, the stimulus package. And so this question is saying, if that was funded through Series EE bonds, I'm not really sure what EE stands for, but a 20-year bond was purchased in order to fund this, and it has a fixed rate of 1.3%. If the federal government financed the stimulus through these EE bonds, how much would it have to pay back in 2029? Right. So we want to look for a future value in this, right? How much are we going to have to pay in the future? So it's going to be A equals, and then we've got 787 billion currently, right? I'll write out the zeros just yet. 787 billion, and then it's 1 plus our rate, 0.013. Number of compounds is 2, so annually, and then 2 times, and then it's 20 years later. So that's what we're looking at. The 787 billion, let's see. We got 1, 2, 3 zeros gives us 1,000. 3 more gives us a million, and 3 more gives us a billion. So 9 zeros. Then times 1 plus 0.013 divided by 2 to the 40th power. And we'll get a long number here to the 12th power. 10198255581. 9, 3 more zeros. 1 there. So I think the government's gonna have to pay back $1 billion. A trillion. Is that right? Trillion? Thousands, millions, billions. Yeah, it's thousands, millions. Yeah, 1,019 billion. So then the amount of interest would be this amount minus the 787 billion. So minus 787,000. So they're gonna have to pay back like, you know, 2. This one minus that one, whatever you guys got. Okay, so yeah, 2 billion. 32 billion. What do you guys got? Maybe with that one. So this one minus 787. Just try out. 825 581 000 787. Yeah, 2.32 e to the 11. So, yeah, 232 billion. Sounds right. Yeah, 232 billion. Obviously, big numbers that can't really understand. But. So let's flip to today's. All right, our first thing we're going to do is talk about an effective interest rate. So we've talked a lot about interest rates, and an effective interest rate just means we're going to take an interest rate and then try to make it just like let's say a simple interest rate. So we're going to take a problem like this, and we have these different, percentages, different number of compounds. We want to simplify those a little bit. So we're going to calculate an effective interest rate. This is just calculating the equivalent of a simple annual interest rate that would yield that same amount. So if we had to convert those to just simple interest, say like this percent per year, what would that percentage be? The annual percentage rate. Can we use this to compare different investments? So if one's offering this percentage at this compound, and another one's offering this one, how do we know which is the best one? Well, we're going to just change them both into an effective interest rate. Well, there's two formulas here. You do not need to memorize these. You can just write them down. Again, it's too much to memorize. But these are all variables we've seen before. This R sub E just means the effective rate. So just write it down. But again, you don't have to memorize this one. The other ones you should probably have memorized by now. So we've used them so much. But this effective rate, don't need to have this one memorized. And then this one, obviously, it has an E with it, right? So this is going to be with continuous. Continuous rate to an effective rate, we're going to use that one. Otherwise, we're going to use this one. So those are two formulas that we're going to need for today. So let's flip back to that problem we started the day with. Give a chance to finish right now first. All right, let's go to this problem. See if we can solve this here now. All right, so let's start with the three banks. First one is Huntington. So we're going to take this formula right here. This is the effective interest rate. We're going to do 1 plus our rate. Our rate here that it gives us is 2.15%. So we're going to make that a decimal and move it two places. 0.020215 over n, our number of compounds. What's compounding monthly? So it's going to be 12. To the 12th power, and again, minus 1. So we're just going to plug all that into our calculator. Just make sure you put this one in parentheses when you type it in. You get plenty of parentheses there. Parentheses 1 plus, parentheses 0.0215, divided by 12. 12 power. You should get 0.0217, right, which is the same as 2.17%. So if we were to take this as just simple annual interest, that would be 2.17%. The next one is Park National. It's kind of the local Newark bank, Park National. Same process here. We're going to take this 2.20%, so it'll be 1 plus, change that to a decimal, will be 0.0220. And this one's compounded quarterly, so over 4 to the 4th power minus 1. And to go through that, you should get 0.0221. The two places, it's 2.21%. All right, and our last one is PNC. It would be a 1 plus rate of 0.0212 divided by 365 because it's daily. The 365 power. One more here. This is 0.0204. So two places we get 2.04. All right, so which one's the best? Huh? Yeah, Park National. Park National is the best because we're investing, right? We're investing, so we want a high interest rate. We're investing, so that means we're going to get a better return. So Park is the best. Now, if this was like a loan, we would want a low interest rate, right? Because we wouldn't want to pay extra interest. But since it's an investment, we want a good high interest rate. So the higher we can get, the better. It's not by much, but it is a little bit better. We want to do that. Park National Bank will be the best.
Mr. Davis,
Yes.
could I please have Tegan Staggers to the attendance office? She is signing out.
Sure.
Thank you.
You're welcome. All right, let's just like another couple, one or two real quick here. Next question here, 3.9% compounded continuously on a savings account or 4% compounded annually. So we need to use the continuous formula here, 3.9%. This is our continuous one here. This R sub E is e to the r minus 1. So to convert this one, we're just going to do our effective rate. And just the e to the 0.039 minus 1. And now the second one is actually already an annual interest rate. It's 4% compound annually, so we're just going to compare it to that. I think the ones in your book are very similar to that. Remember, the E is on the natural log key. And these are really close, but this one you should get 0.0397, which is very close, 3.97. Not quite as good. The other one's 4% annually, so we don't have to do anything with it because it's already annually. So we would want to choose this 4% annually. So those are pretty easy after you do a couple. It's just going to be plugged in the formula. We're going to tackle one more type of problem here. And we saw something similar to this in the quizzes yesterday with the doubling and tripling. We're going to look at that next. All right. So a question. What rate of interest would you need if you had some account or investment that was compounded quarterly if you wanted to double your investment within 7 years? Double up your investment in 7 years. What kind of interest would you need guaranteed to get that? Maybe you're looking for an investment or like even some stocks or something. You want to double your investment in 7 years. How much interest rate are you going to need in order to make that happen? So it doesn't say anything about an amount of money, right? So this would work for whatever the amount of money it is. You can make up some value. Let's say $1,000. So you're going to invest $1,000. And let's just plug it all into our formula. So our A equals P times 1 plus R over N P and T. Let's just say you're going to invest $1,000 and you want to get 2,000. And you'll see here that it doesn't really matter what you pick. I'll just choose this for now. But in the future, we want 2,000. Okay, and we're going to start with 1,000. And then our 1 plus. Our rate we don't know, right? That's what we're going to try to figure out. Our N is the number of compounds. This is quarterly. N is going to be 4. And then we got 4 again. And then the T is 7. All right, so our goal is to solve for the one unknown variable, which we can never have more than one. We just need one unknown variable there. We're gonna try to solve for that r. What would be the first thing I want to do? Okay, divide by 1,000. Yeah. This multiplication will divide by 1,000. So when you do that, you just get 2, right? So 2 equals, and then over here we still got our 1 plus r over 4, and we'll say the 28th power. So the reason why it doesn't matter what you choose is, let's say you chose 50 and this was 100, it's still just going to give you 2. So kind of a shortcut we can do is, you don't have to even put in a value. Since we're doubling it, just say 2 equals whatever that is. With tripling, you just say 3 equals. Because whatever value you choose is just going to divide and give you 2. Okay, so we got to get to that r. In order to get in here to this r, we want to get that by itself, right? We need to first get rid of that 28. How can we get rid of that 28th power? Like, think about, even if this was, let's just say it was a second power. The second power, what would you do? Square root, okay. So the 28th power, what would you do? Yeah, 28th root, right? Seems kind of crazy, but it turns out you can actually do a 28th root. So you get rid of a 28th power, it's 28th root. We're going to 28th root to both sides. Oh, I've never done that before. And there's a way you can do this on your calculator. You want to hit 28 first. I tried to pull this up on my projector earlier, and apparently it's super fuzzy. Do 28 and then do math button. And then go down to there's little X with their roots. So you want to say what that is. 28, hit math, and then there's a little X with a root. Okay. 28 math, X root. And then you type in 2. And that's going to give you a decimal. This gives you 1.025. So 28 math x root 2. And then over here, we cancel that 28, so we'll have 1 plus r over 4. So now we just got to get the r by itself. Subtract 1, right? Times by 4. So minus 1. And I would just keep this all in the calculator. You've got that number in there still, so just hit minus 1. And we'll have to retype it. Let's do 0.025, and you still got all the other stuff in there. R over 4, and then times it by 4. So then, again, don't clear, just sit down times 4. And we get our R is 0.100. This is a rate, that's a decimal. We need to move it over 2 places, so it'll be 10%. 3.0. That's how much interest we would need to double it within 7 years. 10% interest rate. Isn't, I mean, it's a high interest rate, but doesn't seem. I think maybe you would think it would be higher, but you can double it in 7 years with just 10% interest rate. A bank wouldn't necessarily give you 10%, but maybe you could find an investment that earns 10% interest. Be a little bit riskier. All right, let's try a similar one. This one we're just going to look at the continuously compounding. And anytime you see continuous, you should think the E, right? So the E formula, which we're going to write here, A equals PE to the RT. We're doing the same thing. We're going to try to find an interest rate if we have continuously compounded interest. And this time we want to triple an investment. I'm going to try to find, what is this going to be triple? Triple up my investment. Within 10 years. Okay, so as we saw last time, if we were to make up a number, let's say 1,000, and then tripling it would be 3,000, you're just going to divide it, it becomes 3 in this case, right? Just like it was 2 in the last one. So we're just going to write 3 equals, and we want to do it 3 times, and then it's e to the, our rate, we don't know, that's what we're trying to find. Our time is 10 years. So we got 3e to the 10r. Right, that way it's makes a little more sense. All right, so let's think back. What are we going to do to solve this? Yeah. Yeah, we're going to use the natural log. Which, so remember I told you how this was in the natural log chapter, right? I haven't used any natural logs really yet. But there's a reason why this is the natural log chapter. Is take the natural log of both sides. That cancels the e. So then we just got the natural log of 3 equals 10r. And then we can make 5 by 10. R equals natural log of 3. Just type that in. We get 0.1098, so 10.98%. You could probably even round that up to about 11%. Is 10.99%. About 11%, you can triple your investment in 10 years. So you can see like why like saving early in your career, like they always tell you to invest early. You start working a job, start saving for retirement early. Definitely pays off. You can triple it in 10 years if you have a really good interest rate. Okay. And the other aspect, we're going to continue with this, but just one more aspect of it is if we wanted to figure out how long it's going to take. So in the previous scenarios, we said, here's our rate, here's our time, what rate do we need? It's going to work the same way, but if you want to double or triple it, here's the rate, how long is it going to take us to double or triple it? So just solving for a different variable. We're talking about a doubling time here. How long is it going to take for an investment to double if it earns 7% interest compounded daily? So we can use our same A formula. We want to double it, right? So we're going to use our 2 equals. And you could use 1,000, 2,000, we're just going to end up with 2. Compounded daily, so we're going to need our 1 plus our rate. Rate is 7%. Our number of compounds is 365. So N is 365. And then we have NT, which is 365. That's going to be our equation. Think for a second how we could possibly get that to that T. Yeah, an idea? Okay, yeah, you could actually take the natural log again, right? So in order to get up to this T, we need to get that down somehow. And if you guys remember, we have like, let's say we had 2 equals 5 to the x. The way that you can get things down is you natural log them, and then you can bring things down in front. That's one of the properties of natural logs. You can bring exponents down in front. So if we use that same logic here, take the natural log of both of these. This one looks pretty messy, but it works. We have the natural log of 2 equals this natural log is going to allow us to now bring that exponent down in front. So it'll look like this. 365t times the natural log of this whole thing here. It's not pretty, but I might check natural logs. Natural logs let you bring exponents in the front. That was something we did prior to break. Talking natural logs. Okay, and then we need to solve for t. So this is all just a number. It's just a natural log number. It's just a number. So we're going to divide that one over. Both sides. Just a natural log of this stuff. So we'll want to type that in. The natural log of 2 divided by the natural log of 1 plus 0.07 divided by 365. So make sure you use parentheses. And 3,614.64. This is all canceled out now. So 365t. So then our last step is then just going to be to divide, right? And you can just leave this number in your calculator. So you divide by 365. And then make sure your number makes logical sense. I got 9.90.
Bless you.
And we're talking about times, this is years. So 9.9 years. About 10 years. And then an investment would double, you get 7% compounded rate. Got one more, I promise this will be the last one. This is continuously compounding. And we'll do a triple one again. Done. So how long for an investment to triple if it earns 5% interest compounding continuously? 5% seems a little more reasonable. We want this thing to triple. Since it's tripling, we're going to start with 3. We're going to 3 equals 3 times the amount. Then you could do 1,000 and 3,000. You're just going to divide to get 3. It's continuous, so we're going to use the continuous formula, which is e to the RT. So e to the rate is 5%. 0.05 times our time. And that's what we're trying to find. And same strategy on this one, we need to get that t down right. So we'll natural log both sides. And this one's going to end up being even easier. And natural log would be natural log. Natural log of 3, do that. And natural log and e cancel, so bring that down and just becomes 0.05t. Then you just divide 0.05. And we got 21.97 years. So about 22 years to triple. So you're putting them out in an account early on in your career or whatever and ready to retire and it's triple. So that's good. Okay. So with time left, let me give you your assignment, but I'm actually not going to be here tomorrow. So you're going to have some time to work on this tomorrow in class as well. You can work on it now, but I'll probably have like another little video for you to do. But you can work on this in class as well tomorrow. You might want to start now while it's like a little bit fresh. This is a part of it. I won't be here, so it will probably be some sort of an ed puzzle related to this type of stuff. If you want to go ahead and let me actually go over this, show you what type of questions you got here. So the first set of questions are that effective interest rate, which is the better deal. Some of them you got to compute just one, some of them you have to do both. Like the first section here, 27 and 28, you're going to compute the effective rate and compare it to that annual rate. So these you don't need to change because they're already annual rates. These you're going to do both, compare these interest rates. And then you got some doubles and triples of like the rates and the times. So 36.